At the center of any nuclear sector is a nuclear power plant or power plants generating electricity into the grid. While countries such as the United States of America boast of tens of nuclear power plants, plans to put up one in Kenya have gathered steam in recent years ahead of the 2037 commissioning deadline. Tonight, we take you through a model power plant as we seek to find out whether we have what it takes to manage nuclear power plants locally. The generation of nuclear electricity in any country is ultimately pegged on the construction of a nuclear power plant. And with the country having plans to generate nuclear electricity in the future, a plan to construct a power plant here locally is definitely in the offing. And today we'll be taking a look at a model power plant. We are joined by a senior officer at the Nuclear Power and Energy Agency NuPEA to take us through step by step what this power plant will be, its benefits, and how it will reflect on our economy as a country. Thank you, sir. And I'd like you first to introduce yourself, and then we'll pick it up from there.
Thank you so much. My name is Engineer Eric Ohaga, and I'm the Director in charge of Nuclear Energy Infrastructure Development at this agency.
Yes.
Thank you.
What I'd like to understand is, of course, we've had talk of nuclear electricity, nuclear energy, and of course, a nuclear power plant is what comes to the mind of anyone. And another thing that comes to the mind when they hear about nuclear power plant are those, as I was telling you, the chimney structures, the concrete chimney-like structures. But I think there's more to that, isn't there?
Yes, it is. Mm-hmm. Actually, what you are looking at here is basically the nuclear power plant, and you can see it is so compact, it is so small, it's so clean. But the output of this nuclear power plant is enormous, that is capable of driving the economy of any country. Yeah. When you talk about developed countries, the 5 super developed countries, all those countries have nuclear power plants to be able to drive their economic agenda. And as a country, that's why we are here, trying to embark on the development of the nuclear power plant. Because we are looking at reliability, we are looking at availability, we are looking at clean source of energy and cost reflective. And this is what this nuclear power plant is supposed to offer for this country, Kenya, as we aspire to have a middle-income economy by the year 2030. Yes.
Let's get into the model power plant.
Yes.
Where do we start?
Yeah, we start at the nuclear island. A nuclear island is basically where the reaction takes place, and it's the most protected area of a nuclear power plant. As you can see in this particular model, it is divided into 2. That other part is what we call the nuclear island. We have the reactor vessel and we have a containment building. That containment building is about 2 meters in depth, that is supposed to protect any emission that is coming out of that reaction process going out into the environment. So the reaction takes place in the reactor. You can see in the middle there's a reactor there, and the reaction of the atomic takes place in that particular reactor vessel. We have uranium, is our source of energy, uranium-235, and it undergoes a fission reaction. And when it goes a fission reaction, it releases a lot of neutrons and it releases a lot of energy. That energy is what actually heats up the assemblies, and the assembly heats up the water, and then the water goes on up to the steam generator, which is again superheated to a very high temperature and a very high pressure, and then it comes up to here to drive the steam, the turbine generator, and then from the turbine generator it joins the national grid. So this is the typical national grid that then after evacuating the power, it will join the grid to supply our loads.
Mm-hmm. And how long does it take to come up with this now? Not the model one, but the actual power plant in the country.
Yes, any embarking country, and Kenya is one of those embarking countries, requires to use the Atomic Energy Agency milestone approach. And it takes about 10 to 15 years to be able to develop the requisite infrastructure for you to be able to move from one phase to the other phase. So Kenya has adopted that International Atomic Energy milestone approach. We are actually in the very tail end of the first phase, going into the second phase, where we want to start now the siting of a nuclear power plant. So there are 19 infrastructure issues that you have to demonstrate to have accomplished as a country before you can be allowed to move from one phase to the next phase. As I've said, we are in the tail end of the first phase, going into the second phase, now looking at the siting of the nuclear power plant. It takes about 20 years, by the way, to be able to allow to complete the construction of a nuclear power plant. So we are in that second phase, now developing the siting criteria for our nuclear power plant, and then we envisage that by the year 2036, that will be the day for us to be able to commission the first nuclear power plant in this particular country. We are systematically developing the competencies that are required for purposes of running a nuclear power plant. And for example, a typical nuclear power plant of about 1,000 megawatts would require about 800 competent, skillful staff. Countries like Kenya has been having several MOUs with countries like the US, South Korea, China, and Russia to be able to adequately train our personnel at master's level and also at graduate level, so that by the time we reach 2036, we have competencies to be able to undertake this particular program.
When you speak of siting, is this what you meant, like identifying a location for the plant now? Which is the ideal place probably? Which areas, which locations are you considering in this case?
Yes, this activity started in the year 2016. It's taken about 5 years. Site evaluation is again another process that you're required by the International Atomic Energy Agency, that you go systematically. So we started by looking at 3 regions in this country, along the coastal region, along the Lake Turkana region, and along the Lake Victoria region. What is common with these 3 regions, you can see there is availability of mass of water for purposes of cooling. As we said, this nuclear reactor produces a lot of heat, about 2,000 mega electrons from that 1 gram of uranium. And therefore it has to have a very big mass of water for purposes of cooling so that the temperatures are maintained. So those 3 regions have, first of all, one common thing, that they must have water body. Then we did the analysis and then used some exclusionary criteria to be able to eliminate certain regions. Of course, regions that are within the Rift Valley Fault are eliminated because of the safety of a nuclear power plant. And that's how Lake Turkana region was eliminated, because it's within 30 kilometers along the Rift Valley Fault line. In the event of earthquake, you expect this particular nuclear power plant to shut down. And when it shuts down, actually it becomes a safety issue. So we eliminate areas with such kind of scenarios. And again, the Lake Victoria region was also eliminated because about 70 kilometers off the fault. Now we are left with the coastal regions. It has a big mass of water, and those 5 sites within the coastal regions were further evaluated and then ranked from number 1 to number 6. Currently, we are looking at our best site and alternative sites where we want to carry further detailed engineering analysis, where we are calling site characterization, so that they meet all the requirements, and then you should be able to say site A and site B 100% meet those particular requirements for purposes of commencing the construction of a nuclear power plant. So we are looking at those 2 sites along the coastal region.
Yeah. How long perhaps does this particular phase now do you see it taking?
Okay, the site characterization will take about 3 years. That is what we have. We've benchmarked with many other countries, of course, that are currently undertaking such kind of activities. We've seen they have been able to take about 3 to 4 years to be able to complete the site characterization and then make a commitment that this is the best site for us to continue with.
There has been concerns that, not concerns actually, the demand for power is basically on the rise.
Yes.
Yet the supply is wanting, and that's where now talk of nuclear electricity comes in.
Yes.
Is this one plant that perhaps you see commissioning by 2036 enough to fill that gap? Or perhaps moving on, we might need more and more plants? Actually, can one plant run a country?
Yes, this country is driven by planning, and it's called a least cost power development plan. And we have various energy mix. Mix is just a combination of various sources of energy. And in this country, we have sources like hydro, we have geothermal, and we have thermal generation. We also have renewable sources like wind and solar. So you bring all this together and you have the national energy mix. And through that planning team, then you look at how is your demand growing. What do you want to do by a certain year? It's a 20-year planning period. Now, this birth of nuclear power plant was occasioned by the flagship projects by the year 2008, 2010, that we are looking at very mega infrastructure projects that were supposed to be powered by electricity. And therefore, when they looked at the available sources of electricity in the country, they found that they were not adequate to meet that particular demand if you project it to the year 2030. And that's how the nuclear power plant was brought on board. For us to be able to achieve that particular mandate of driving that particular economy, then we require reliable, stable. Nuclear power plant is a base load. That means it runs for 2 years without a shutdown. You can imagine enjoying power without a blink for 2 years. You can only bring it out when you want to maintain, but not that it will trip after 2 years. So it provides that reliability that a country that envisages to develop in terms of industry would actually be supplied by a nuclear power plant. So that is what normally informs the planning. You look at how your demand is growing, and then you match your demand with the supply. So when the country projected its demand up to 2030, it found that there was going to be a gap if they had to continue with the conventional sources of energy. And that's why the nuclear power plant had to come in to fill in that particular gap.
But do we have the capacity locally to run the nuclear industry, or shall we have to rely solely on foreign input?
So when I talked about the 19 infrastructure issues that requires a country to develop, one of those issues is called industrial involvement. And at industrial involvement, we are looking at the localization percentage of a country at that particular time when you are considering the development of a nuclear power plant. And as many embarking countries have had, that we would have a situation whereby the vendor comes in on an EPC contract where you build, own, operate, and then transfer. And the reason why we go into that particular arrangement is because of the complexity and the competencies that are required for the development of a nuclear power plant. So in the beginning, of course, we will not be able to achieve that localization content that we are looking at, but I can assure you within a period of about 15 years, that particular percentage will have improved. As we look at our situation right now and looking at that localization capability assessment, without nuclear power plant, this country stands at about 2%. But within a period of about 5 years, that particular percentage would then be able to be improved to about 20%. So as we continue to gain experience, as we continue to train our people, we should be able then to move to about 90% experience level. There are countries like South Korea, whose first nuclear power plant was commissioned in the year 1978. They are achieving their 98 localization level this year. Now look at those years, about 40-something years in operation, and they're achieving their almost 97% localization after that number of years. But I think with the kind of operating experience that people have gained over years, it's been lessened. The time period has been lessened in terms of full localization. So that's a very critical component which must be demonstrated by a country, that you are doing everything possible to ensure that the local content is factored in as we even embark into the development of a nuclear power plant, so that the country can make use of its people in the development of the nuclear power plant. Mm-hmm. Yes.
Let's move on to another topic, and that is related to safety. How guaranteed are the Kenyans that once we have a nuclear power plant up and running, the country won't be a statistic in the countries that have dominated headlines in terms of nuclear disasters? How guaranteed are we that, especially those around these plants and the country at large, that it's going to be safe?
Kind of designs and the developments that have been going on across the globe in improvement of the design criteria, being conservative in what is it that you can imagine. And they have been using probabilistic risk assessment, whereby you try to imagine anything under the sun that could go wrong in a nuclear power plant and make a provision for it in the design. And as a result of that, we have seen that the design levels and the probability of a core damage frequency, that is an accident happening in a nuclear power plant, has continued to move almost to zero because of those kind of safety features that have been enhanced in a nuclear power plant. As I've said, we continue to develop from generation 1 nuclear power plant, we move to generation 2 nuclear power plant, generation 3 nuclear power plant, which are currently operational, and then we are moving to generation 4 with very enhanced safety feature. Safety is critical in a nuclear power plant. You don't look at costs. You first of all ensure that Safety is taken care of because of the aspects of the public and the environment. You take care of that, and then you can move and look at the issues of the cost. So in the design of the nuclear power plant, they assure you that there will be no accident, and in the event of an accident happening, then the mitigation measures are also assured so that you minimize any adverse effect to the environment.
You actually mentioned something about, when you talked about safety, you also consider the environment as well. And in as much as nuclear power plants do not directly produce carbon emissions, there's the issue about waste management. And you'll agree with me that if this waste is not managed carefully, then it could be a problem for the country. How are there measures, are there plans for waste management in this case?
Yes. As I've said, due to these infrastructure issues, 19 of them, and one of them, the number 9, is called waste management, radioactive waste management. And a country has to demonstrate that you have put policies and strategies in place to manage your waste. Normally, for a country that is embarking on a nuclear power plant, there's an organization called the owner-operator, that body that operates a nuclear power plant. And as we saw in the nuclear island, that is where we are talking about the radioactive material being stored. And we said that you have that nuclear power plant operating for 24 months without any hitch, and then you remove the wastes. When you remove the waste, you are replacing that particular fuel. And that is what we call the high-level waste, because that is what people are concerned with. Within the same nuclear power plant, we have spent fuel pools, whereby once you remove your wastes from the reactor, you place it in that particular spent fuel pool, and it will be there for 80 years. For a matter of fact, the current designs that we have a lifespan of 80 years with an option of extension of a further 20 years. So when you have a nuclear power plant today, we are looking at 100 years of operation. So within 100 years, you are sure of managing your waste within the nuclear power plant. And at that particular spent fuel pool within the nuclear power plant, which is protected within the island, the reactivity levels goes down. You have moved from about 5%, it's now going to almost 0%. You know, a fission process goes to infinity. So by the time it's removed from that spent fuel, that reactivity level of that fuel has gone almost to a 0% in terms of radioactivity. Then within the same nuclear power plant is a provision for you to remove them now from the spent fuel pool to dry casts. So those are the strategies of managing the spent fuel. You remove them now from the spent fuel pool to the dry cast, and then you place them in the dry cast for further reactivity levels to go down. Then from the dry casts, you then take them to permanent reciprocatory, where they can now stay forever as they go to zero waste. We have made, the globe has made a lot of progress in terms of waste management. Countries like Finland, countries like Sweden have already established permanent reciprocatory for the nuclear waste. That means countries can now take their waste that have gone almost to 0% reactivity levels and store them permanently in those reciprocatories in Sweden and in Finland. Countries have come together like in a block, and they construct such kind of permanent reciprocatory for purposes of nuclear power plant. So that is how we manage waste for a nuclear power plant. So we are starting to think, after 100 years, where are you going to take this waste that has gone almost to 0%, but reactivity levels will always take several years before they can almost be said that they are now non-reactive. So they are put in those permanent reciprocatory. In this country, we have Ololua in Kajiado County, where we have a reciprocatory for conventional wastes. You know, Kenya has conventional waste, nuclear conventional waste that you use in hospitals. So they collect those wastes, they are called low-level wastes, and they put them in that permanent reciprocatory. So we shall have a similar permanent reciprocatory, which is a responsibility of the operator of a nuclear power plant, that you establish a permanent reciprocatory for high-level waste for complete storage. So that is provided for under the infrastructural issues.
Yeah, quite assuring. To sum it up, you are alive to the fact that as a country our debt is rising, and then there is talk of nuclear electricity generation. Won't this be a financial burden to Wanjiku in this case?
In many arrangements that we have seen, it is on a, let's say, a PPP arrangement, where the vendor is coming with the design, is coming to construct, and is recouping his investment and then transferring that particular investment to you now to manage. As we have said, this nuclear power plant will run for 100 years. A nuclear power plant would be able to recoup its investment on the 17th year. Imagine 17th year you have recouped your investment and you have 80 years to make profits for a country. And that's why we say the levelized cost of electricity emanating from a nuclear power plant is very low as compared to all these other sources of energy, including geothermal and even hydro, because it will go as low as $3 per kilowatt hour in a levelized cost of electricity over a period of 80 years. Country reaping from an investment which is already paid off.
With NuPEA buoyant of intense but brighter days ahead for the country, we take a break, albeit short, and when we come back, trust me, our interview with this queen in the nuclear sector is one you won't want to miss out on. Then later, we have fresh Did You Know, My View, and IAEA in Action segments that will sweep you off your feet.